us release products and our features every 5 weeks. And what Matt Watson is going to talk about today is how we actually do that, how we have our team structured to do that, and our processes as well.
Thanks, Jesse. Hey, everybody. Thanks for coming. My talk today is about rapid agile delivery, but first of all, I just want to say something about being here at Summit and having all you people here. I've had heaps of people come up to me down at the Demo booth and in the Guru Lounge over here and talk to me about Stash and their experiences using Stash or how they want to use Stash. And it's just awesome to get that sort of feedback about that sort of effect that we're having on your development processes. I'm really proud of our team and I'm really proud of our products. And I'm excited to tell you some of the stuff about how we develop that in a rapid way. So this is a tweet from one of our customers. I'm going to be talking about the dev process improvements that we've put in place, some of the challenges that we faced and how we overcame those challenges in getting to the point where we're doing that 5-week release cycle. Now this tweet says a couple of things to me. One thing, it says we're doing release early, release often. So we're doing every 5 weeks. We're obviously doing release early, release often. And that's one of the tenets of agile development, is that you get that stuff out in front of your customers as quickly as you can. But the other thing he says here, we're doing it properly. So what I take from that is that we're not just doing release early, release often. We're not just putting out a release of whatever we've got. We're putting out really good stuff. We've got some quality features in there. We're putting out stuff fast and getting it in front of you guys. So I want to tell a little bit of the story of Stash. We started developing Stash a little bit under 2 years ago. So this is a timeline of our releases over that period of time, over the last 2 years. So you can see the first release there went out in 6 months exactly. So we started off doing Stash. We decided that we wanted to have a completely new product that was really focused on what we wanted to do, which was to make the best enterprise Git hosting product that we could. So to do that, we knew we needed to be totally focused on what we were going to do, which was one of the reasons we decided writing a new product from scratch. However, there's heaps of stuff that you need in a product that isn't actually focused on your end goal. We needed to have user management. We need to have permissions. We need to integrate the Atlassian plugin system, make sure everything worked really well, that we had a really solid foundation on which to build. Well, that took a lot of time. We needed to come up with a completely new front-end architecture, completely new back-end architecture that would future-proof us so that we would be able to keep going fast. We then settled into a more rapid release cycle. So what we needed to do there, we knew that in that first 6 months, we wanted to get our product out in front of customers. Not just to get that early feedback, to let you guys know that we existed, so that when you came to think about a Git hosting service, you'd think about us. So why did we want to do the release early, release often after that? After that 6 months of development, what we had was basically a minimum viable product. That's what we called it. It had the minimum feature set that we thought we could put out in front of people would think, oh, okay, it's a Git hosting service. But we knew that we were actually way behind some of our competitors in the features that they offered that we didn't yet offer. And we knew that we needed to catch up as fast as we can. So we needed to go as fast as we could. We needed to be adding value for our users, for our customers, for you guys, as fast as we could. But not only that, we wanted to convince you that if the feature wasn't there, we would have it as soon as we could, so that you would consider us a viable solution. Some of the other reasons for using release early, release often are more standard. You know, we wanted to have smaller changes. We got less amount of risk. We get earlier feedback from you guys to make sure we're going in the right direction. We don't go off and develop a huge feature in a 3-month release cycle and then release it out and go, wow, nobody really seems to be very excited about this feature. So I want to talk now a little bit about our team as well. So previous to Stash, we were doing quarterly releases. And in my experience, we went through a productivity cycle that the whole team went through that looked somewhat like this. So we'd start working on our release about at this point. We're in the sort of the middle area of how productive our team can be. But we immediately dive down into a hole while we're trying to figure out what we're doing. We're looking at the specs that we've got from the PM. We're trying to figure out how we adapt those into actual code. It's taking a while to get going. Once we start getting going, we start to speed up. And then we start to cruise along. We're really going really well. Beyond that point, we may actually hit a bit of a high here And the high is when maybe we've got a deadline coming up and everybody's working a bit too hard maybe. We don't want people to burn out, because when they burn out, they drop down the bottom on the other side. So then we've done all the code, we're doing bug fixing and docs, things start to slow down again, and then we do the release. So we're going through this release cycle over and over and over again. So what we want to try and do is avoid this ups and downs by releasing more frequently and keeping the team on a higher level of pace, making sure that we've got more focus on what we're doing, and making sure that everybody's as productive as they possibly can be. Remember, our goal is to release customer value to you guys as fast as possible. So not only is it good for the product and good for the customers and good for feedback, it's good for the development team. We get to do some other things here. Because we're releasing so often, we don't have to say, hey, we're going to put this feature out in this version. We actually have a fixed release cycle, but we don't necessarily have to lock in what features are going to be in a release. We can say, well, if this feature's not ready, we're not going to ship it. I got reduced stress there. It's like, so we hit that point where the team members are burning out because they're working too hard trying to get a feature in because we've got a deadline. We don't necessarily have that anymore, because we can say, well, look, if it's going to be too much work to get this in this release, we'll do it in the next release. Don't worry about it. We've got other stuff we can put out. We never drop our quality or scope for a particular feature either. We're always considering that we want to have a minimum feature set that we put out for any feature, that it's going to be this level of polish, so that people are going to really gel with that feature. So we never have to cut that back in order to fix it into a timeline. The timeline is fixed, but the feature set is flexible. So what we're doing is we're focusing on breaking our features down into small as possible units. Right? Smallest features that we can, which also means that we have more features. We've always got something to release in any release. I'll talk a little bit more about that in a moment. Now, there are times when we're not able to break down a feature as small as we'd like it to be. So we've had two quite big features that have taken us a long time to put in the product. So the first one of those we had was when we put pull requests in. Pull requests, it was pretty technical. It had a lot of front-end and back-end work that we had to do. And to be honest, we actually could have released a release early, but we held it back because we figured that people would look at our pull requests and go, wow, that's not a very compelling pull request, because I've seen pull requests in these other competitors and that doesn't look quite as good. So we held it back till we had more of a complete product for that. And our fork support was also very, very technical, lots of going into Git and how Git works, and we had to have a small part of the team develop that feature over multiple releases. So we weren't committing our whole team to a long release cycle, we're just committing part of it. And they're still caught up in the rhythm with the rest of the team. So now I want to talk a little bit about how we actually do that feature development. So we had some challenges early on. One of the big ones was lack of feature ownership. If you've ever worked on a product that's had a really distant deadline, you'll probably gel with some of these problems. So first off, we had a front-end team and a back-end team. The front-end team, and this actually worked really well for us in some regards. The front-end team was really focused on the front-end architecture. We were building a whole new product from scratch. We had to make sure we got that architecture right. And the same for the back-end team. They needed to focus on that together as a team to make sure that they were all on the same page and that we were doing the best thing that we could. However, when it came to developing features on top of that architecture, we'd then have some mismatch and misalignment. The back-end team, which I was the team lead of, perhaps we'd deprioritize something that the front-end team, they'd get blocked, or we'd end up implementing the wrong thing and we'd have to have a week of back and forth to resolve it. We had a really long time frame. So this meant that people would see bugs in the product. They'd perhaps even raise a JIRA. Sometimes they wouldn't raise a JIRA because they think, oh, well, look, we've got 4 months until we're delivering. We'll probably clean this up later. And then we'd end up getting towards the end of our 6-month block there and we'd have a whole pile of bugs that we had to run around and fix because no one had actually considered them important enough to fix earlier on. Another related problem was the fact that we had so many different things to do. We'd be writing JIRAs and putting them in the backlog. A developer would pick it up, read the JIRA, go off and implement what it says, and then check that code in. And what we've got there is we've got a lot of missed edge cases. So there's a little thing where our help links aren't right, we're missing some text, help text or something like that. We've got pixel alignment issues. Before that initial release, we had to run around and clean up a lot of stuff. And of course, that put the team leads under pressure. We were sort of responsible for making sure that everything was getting into the pipeline that we needed to fix. And this became a problem when we start moving into a more rapid release cycle, we're trying to put more features in parallel development at the same time as possible. So we've got more features to put out. We've always got something to release. We've got more features going on. We've got more stress on the team leads to manage all that stuff. So one of the first things we did to tackle some of these problems was to really give that ownership of the features back to the developers. And when we call this feature kickoffs. So what we'd do is our product manager and our designer would get together and they would take the concept of a new feature that we're working on to a certain point. They wouldn't go into huge detail here. We didn't want to burden them with going into that huge detail. Instead, we get into a meeting room with all of the stakeholders of this feature. We get the QA guy in, the PM, the designer, all the development team, anybody who's got any input into how this feature is going to work. We all get in a room, we put the mock-ups on the wall, and then the developers start looking at it. First thing we get from the product manager, why are we doing this feature? What's the point of it? Really get that into the heads of the developer. And then all the developers would take post-it notes and write up questions about this spec and stick them on the wall. And they're writing up all these questions. Basically, the goal here is to get the developers thinking about, well, what if I do this? And how does that work? If I click that button, and what's this going to happen? And they know how the code works. They're going to think, well, that's not going to work in our application properly. It's not going to do what you expect it to do. We're going to have to do a lot of work if you want that, but if we do this, it'll be simpler. So we've got a lot of feedback in this session between the developers and the product manager. Out of it, we get a whole bunch of questions, which basically we're trying to get rid of any of the ambiguities that are in the spec, and we're trying to deepen and broaden the spec. And we're doing that in a collaborative way in a kickoff session. The developers are really getting their head around how is this feature going to work and what am I going to have to do. Something else we do is we nominate someone, or someone puts their hand up and they say, yeah, look, I'd really like to be a feature lead. So they take responsibility for this feature. And when I'm talking about a feature here, I'm talking about a feature that's possibly made up of whole dozens of stories. And they'll put their hand up and say, I want to be the owner of this feature. And then when they're in that feature kickoff, they're taking all those questions and they're starting to maintain the spec. They take it off the hands of the product manager, and they're the guys who are writing those questions down, prodding the product manager to get questions if there's anything that needs to be resolved. The great thing we push people to do is to say, well, you come up with an answer. You put your best answer on there, and the product manager is going to come along and say yes or no to that answer. So we're actually relieving some of the stress from the product manager because he's got a lot of stuff to do too. And him and the designer are doing this just-in-time feature specification where they've got a lot of stuff in their head, but during that session is when it all gets written down by the people who are actually going to write the code. The developers are really getting their head around what's going on here. And they become the end drivers of the quality. So they're making sure that they own this feature all the way through from defining the stories. They're monitoring the performance of this feature. They're thinking about how am I going to brief the support team when this feature gets released. They're thinking about, do I need developer docs? Do I need documentation? Have we got enough information if someone raises a support request? All this stuff is down to that guy. So the benefits we get out of this, the developers are really highly engaged with this story. As I said, they're carrying the burden of this and they're making sure that this feature looks good, right? It's on them. The team are looking at them going, wow, you did a really good job there, right? They really want to do a really good job. We get really complete high quality features. So that stuff that I talked about, where little edge cases and pixel alignment, people, they sat in that meeting room and they went through all that stuff and they go, I'm here, I'm going to do that now. So we don't have the overhead of having to raise another Jira and go through sprint planning and then schedule it and story point it and all that. Someone's just done it. It doesn't happen anymore. The developers are getting really, really useful experience for their own careers, right? So they get excited about that. They want to do that. Some of the developers in the team are starting to push to do this more and more and more because they really like it. And there's also less work for all of the PM, the designers, and the team leads. We're able to spend our time doing more things, being more forward-thinking, thinking about what we're going to do next. So something else another challenge we face is actually making sure we have enough to put in a release. If a release is coming up and we think, hey, these are looking a bit risky, let's put it in the next release, the first thing you guys would say is, well, what happens when you've got nothing to put into a release? Well, history will show we've actually always had something to put into a release, but sometimes we need to fill that release up with a few extra things. So we have innovation weeks. So an innovation week is basically our 20% time. So in Atlassian, we have 20% time, which is 20% of the time that you're at work, you're allowed to spend working on whatever you want, as long as it's improving Atlassian's products, experience, something that we need. Now, during our initial 6-month push, we actually didn't do 20% time at all. We said, this product is so urgent. If you want to work on this product, which we think is really cool, there's no 20% time until we got it shipped. But once we did, we wanted to give the developers time to get back earn that 20% time back, right, and use it for themselves. So we started saying, well, this week, we're just going to do 20% time. And since that point, that's actually how we've been working. 1 out of every 5 weeks, when we say we've got a 5-week release cycle, one of those weeks, we're not working on the backlog. We're working on whatever the developers want to work on. As a result of this, in almost every release, 90% of our releases, I think, we've had features that have either been initiated or thought of or spiked or prototyped during Innovation Week. A lot of them have actually been completed in Innovation Week and put into the product during Innovation Week. But these have added to the fact that we've always had something to put out in a release. We've always got lots of little features. And these are outside of the scope of what product management might think of in terms of his 12-month backlog, his roadmap, where he's thinking big stuff. But we've got lots of little things in there, right? There was an awesome list of features there, all of which have come from our developers. One of the cool things of working at Atlassian on developer tools is that our developers are our users, right? So they often come up with really cool ideas as well. So this is another tweet from a customer. Look, this is just sort of validating some of the approach that we've taken, right? We have really been working hard to make sure we're putting out really good quality releases, and we've got our customers tweeting about it, which is just awesome for us. So now I want to talk about actually a little bit about how we go through our development cycle of coding and some of the tools that we use to make sure that we have that high quality. So being a Git hosting service, of course, the first thing we do is we use Git to develop our code. You've heard, I'm sure you've heard Scott talk, and there's been multiple sessions of people talking about branching in Git and stuff like that. There's heaps of value in using Git and in branching. So it allows you to develop in isolation. So not just from whatever changes is going on in your stable branch, but actually from the people on the stable branch are isolated from whatever changes you're making as well. So in the typical Subversion model, where everybody's committing to trunk at the same time, you're having to run continuous integration to make sure that nobody's breaking things as they go along. When you're using branches like this, all these changes are segregated off, and we're able to gatekeep things to make sure they're of sufficient quality. We're able to just test that feature itself and make sure it doesn't break any of our functional tests. We're able to look at the performance of that feature and make sure it's not regressing any of the performance that we care about so deeply. As I said, we isolate the stable code from the work in progress as well, so we're not affecting anybody else's work there. If people actually merge their branches back to the stable development branch, we can pull that code into our feature branch and make sure it integrates if we want to. And lastly, we only merge when we're ready. So this is the way that we can keep features out of a release, but it's also how we're gating the quality in our product. We're making sure we've got a certain high level of quality there. Without branching, none of this would be possible. Again, we're as well as being a Git hosting service, we're a code review tool, really. We've got pull requests in there with some quite powerful code review features. We use these a lot, right? This is where we want to make sure that we guarantee the quality of our shipped product. So we've just recently gone and instituted some core values for our development team. And one of the main core values that we came up with, one of the easiest ones to come up with, which we've called dev speed through quality. So that our whole team has got to focus on the fact that as long as we keep the quality high, we will be able to deliver features faster. Everyone feels the pain of when we've introduced technical debt in a feature and it slows us down. Somebody gets pulled off development to work on bugs or to work on support issues. It slows our feature development down. We'll do whatever we can to try and avoid that. But what it actually means is putting up extra effort up front to make sure we've got a really high quality in our code. And to do that, code reviews is one of the great features that we do. We also improve the developer skills. So we'll put people on a code review who aren't very experienced in that particular area that they're reviewing. I mean, you would think, hey, I want somebody who really knows what they're talking about to review this. But you also put on people who aren't as skilled because they get skilled up in doing that review. They'll see the feedback that I'm getting. they'll see the code that I've written, they'll get more experience in it. We get more of the team able to work in more of the code base. It puts less reliance on single people for single areas. It's just a way of educating people. If I'm not very skilled in something, I can be working on something, getting really valuable feature, and vice versa. And as I said before, it's a gatekeeping process as well. We don't let this code go in unless it meets our quality criteria. It becomes such an integral part of our team that this just becomes part of our development culture. People would insist on this. There is no one in our team who would ever go and work anywhere else in an environment where they didn't do code review, or they'd be advocating for code review. And this has actually happened when we've had secondments to other teams where people have said, well, we do code review a little bit different in the Stash team. So you will have seen this in Scott's keynote yesterday. This is what a pull request in Stash looks like. And the same way that Scott called it out, I'm going to call it out. It's this section over here that's the really important part for gatekeeping that quality. We can see who all of the reviewers are on this piece of code. And we can see that in this example, they've all actually approved this pull request. So we can make sure that the people who are supposed to be reviewing this code have said, yep, this code's okay to go. We've got a build there, so it's showing us that we've got one build for this code on this pull request and that it's green. The way this works in Stash is that if there is a single build against this pull request and it doesn't pass, that icon's red. And you can click it and it shows you all the build results. But this is a very important part of our gatekeeping process. There's no way we'd merge a pull request if that's not green. So the other part that Scott didn't show was actually that we can enforce this in Stash. We have these controls that an admin can set on a repository that says, you cannot merge this unless this many people have approved your pull request. You cannot merge this if it has a red build. So initially, we used these controls. We had these set. We said, you must have green builds. You must have a certain number of reviewers. But as I said, this way of working becomes ingrained in the culture of the team. People start saying, I want it to be this way. And in certain circumstances, these become cumbersome, these controls. And we've actually pretty much turned these controls off pretty much all of the time now. And we let the developers monitor this stuff themselves. They will make intelligent decisions about whether they should be merging code or not, because they're the people who are invested in keeping the quality bar high. Now, there is some cases where we actually still impose some of these controls. And if you were here in the last section, you would have heard Stefan talk about the release management plugin that we actually have in Stash. And this is a plugin that we're thinking about putting out publicly. And instead of having a really locked down gatekeeping model, it sort of lets someone say, yeah, I'll let this feature pass. And so you have one person who must approve it, but they don't have to be the merger. No one can merge it until that approver has approved it. But once they have approved it, that can be merged in. We tend to impose that on our release branches. So we really rely on our continuous integration to make sure the quality is high as well. We've got what we consider to be pretty good coverage of our whole code base in a testing framework. So what we do is we have a commit onto master on our master branch. Our master is our development branch. This is where we're developing the next version of Stash. So a commit comes onto master. It immediately triggers a build. So we've got one build as our master build. There's a set of things that it's doing. It's doing check style checks. It's running our unit tests. It's running our suite of browser-based tests. It's running a suite of REST-based integration tests, so testing permissions and edge cases. And I think it runs up Stash and makes sure that it can actually set itself up if it was a new installation. As soon as this goes green, every time this build goes green, we deploy to Stash Dev. Stash Dev is our internal hosting service for the Stash code base. So we were actually been doing this for a long time. Every time this build goes green, we upgrade our Stash Dev instance. It means it's down a few times a day, but this deployment tends to be pretty quick. It takes like 1 or 2 minutes where you can't push or do code reviews. But we're always seeing whatever's the latest thing on master in our own development instance. We're the only team that uses this, so we're the only team that gets inconvenienced by this. This has actually rarely failed to work to come up. I think probably in the whole lifetime of Stash, there's only been less than 5 instances where it hasn't come up after an upgrade like this. After that master build passes, we also run a whole battery of other tests. Now these tests are much more time intensive, they're more specific, they're less prone to failure in many ways. So we run Git tests because we want to really make sure that we work with all versions of Git. We run We test Stash's Git integration against the latest version of every minor version of Git. We do that on Unix, we do that on Windows. We also have a database matrix test. We run all of our database tests against every database that we say we support. So there's actually about another 3 or 4 builds. We run a source build, a couple of other builds I can't recall at the moment. So a whole battery of tests that fire off once that master build has gone green. Whereas if someone commits to master and it ends up breaking the master build, the first thing we do is we go and jump on it. It's really, really important that this build is green as much as possible. And the act of having branches and pull requests ensures that we can keep it green as much as possible, because when somebody creates a branch, a feature branch to start working on, we create a branch build. So Bamboo is automatically configured to create a branch build, and that runs its own special branch build. Now, in an ideal world, we would run that entire set of tests that we run on master would run on every branch. In a practical world, that would require an enormous amount of CPUs and I/O and bandwidth, etc., or a massive number of EC2 instances to spin up to handle all that load for all the branches we have. Instead, what we have is we have a cut-down version of the master build. And the first thing it does is it runs the really high-value and fast tests. So it runs the check style checks, the licensing checks, it runs all of our unit tests, and it does a really basic integration test of Stash. But we use a feature in Bamboo called optional stage builds. So in that first stage, we run about 4 jobs in parallel. Once they all pass, typically they can actually pass in about 3 or 4 minutes. So we get really, really fast feedback into Stash from that. We then have the next stage, which is running all the browser-based tests and all the REST-based integration tests, which takes longer. They take up to about half an hour. But that's an optional thing. So if a developer thinks that they're concerned about the change they've made, they can go in and start that next optional stage. And again, that build result gets reported back to Stash. We leave it up to developers' discretion to decide if they should create a branch plan of any of the other builds that run, the database build or the Git matrix build. If you've touched the Git code, if you touch the database code, it's a good idea to create a branch build of those and make sure they pass as well. And because all of these builds report their status back to Stash, you'll actually see all of those results in your pull request. So this concept of delivering continuously to our Stash dev server, we've been doing that since day 5 of our development. We had it set up really early on. Really early on, we were able to actually take our Git hosting code and put it into our initial code base, which was really quite cool. We were self-hosting from about day 2, I think. So another really important thing is to actually get people to react when these builds go red. So we have 2 46-inch wallboards in our office. So we're a team of about high teens, 18, I think. We've got 2 of these 46-inch wallboards that are in people's faces so they can see when these builds go red. This is really important to jump on these things. And we've got a 28X. This screenshot's from a while ago, so don't worry. This got fixed before 280 went out. But this 28X DAO test, which is the database test, was red here. And it's like somebody jumps on that and finds out what's wrong with it. Who broke it? It's a Bamboo feature. You can see there's somebody's head there on that red build there. We can actually see who broke it there and go off and say, hey, what are you doing about fixing this build? Stash does a lot of integration with Git. We call Git a lot. Git, especially a Git clone, can be incredibly CPU and memory intensive. It's really important that we look at how Stash is performing and handling that. We need to be able to handle enterprise scale load. Right? So that means a lot of the operations that we do in the Stash UI, as well as in the Git hosting, require calling out to Git to interrogate it for information. And the actual forking to call out to Git and execute Git is an overhead in itself. So what we have is we have a lot of browser-based performance tests. These actually test the user response time of loading up certain pages and doing certain operations in Stash. We run these. So the tests take about 2 hours to run, so we don't run them on every commit, but every 2 hours when there's a new commit, we have a new run of this performance test to make sure that we're not regressing anything in our performance. The other things that we're able to do here is we're able to run this build for any feature branch. So if somebody's doing a library upgrade or doing something that they think might affect performance, they can actually go and manually kick off one of these builds and compare it to the last good result that there was and see if they've shifted the performance at all. We have a daily build of this that we check in stand-up to make sure that we haven't had any regressions overnight. So you may have heard Jens talk last night about the release branch auto-merging feature. So that auto-merging feature has risen out of something that we found a necessity in our own development, the way that we do development. So there's sort of two branching models you can use. And one branching model is designed for like a SaaS system where there's really only one instance of your product and it's out there in production all the time and you know which version's in production. In Stash, we've got thousands of users out there, thousands of instances of Stash running, all different versions of Stash. We have to maintain all those versions. If there's a major security bug and it's found in a really, really old version of Stash and some customer wants to stay on that version, we have to fix that bug. And how do we do that? We have to maintain a release branch for every release that we've ever had. So when work happens on master, we work on master and we create a release branch for the next upcoming release. We do some bug fixing for that release on that release branch and then when we release it. We keep working on master for the next version. So when the next version we think is ready, we create a release branch for that version. But what we do then is when we're doing that bug fixing while we're putting that version together, we create a pull request. That pull request then gets with the bug fix in it and it gets merged to our release branch. We immediately merge that release branch back down to the next development branch. We're always making sure that every bug fix that we do in an old version of Stash gets merged down and will be incorporated in all subsequent versions of Stash. If we need to do a bug fix on a much older version of Stash, then we make sure it gets merged down through all those release branches all the way back to the next development branch. We do this all the time, and we've had an automated plugin that did this for us. It just had a really bad user interface that only we could have understood. So in 2.8.0, we've actually tightened that up a lot, and we've packaged it up, and we made it a feature of Stash that you can do this yourself. So this is really useful for a model where you need to support multiple versions of your product. Something else that's really, really important in being able to move fast is the ability to automate all of the manual processes that you have. So when we started out, when we did the first release of Stash, I was basically just typing in commands and then writing them down, saying, right, this is what I did. I was making it up on the fly. We then refined that a little bit. We then turned that into a Confluence page with little code sections that you could cut and paste into your terminal. Eventually, we turned that into a shell script that you could run that took arguments. And finally, we turned that into a build that runs in Bamboo. And now, since Bamboo's got deployments in it, we're using deployments to do this. So when we do a release build for a release of Stash, we need to take different parts of that release and deploy them to different areas. We've got developer documentation that has to go out. We've got distribution builds that we make that have to go to our download server. And then we actually deploy Stash internally onto different instances that eventually ends up on the instance of Stash that Jira and Confluence use. So we've got separate deployments for all those things. It's really important to try and automate as much as possible because what we find is there's like one or two people on the team who've got the permissions to do a certain thing, and if they're not around, you can't do it anymore. Or you're relying on some environment setup that they've got in their shell environment or something like that, and so they're following your instructions on the page, but it doesn't work for somebody. When it's in here, in Bamboo, it's in a controlled environment. We know exactly what it's going to do. It's a repeatable process. We're trying to do this every 5 weeks, put out a release, as well as bug fix releases in between. We want to make this pain point as low as possible. It's the only way we're going to be able to move as quickly as possible. So it's almost like one of the benefits of forcing ourselves to release more often is that we feel this pain more and we get rid of it. If we weren't releasing as often, we'd probably just live with a really awful process that was basically sucking up our development time. Remember I said our goal is to make sure that we're adding value, giving value to you, our users, as fast as possible, right? So I just want to recap over what I've said. So release often. Releasing often is not the end goal. The end goal, as I said, is to add value to our customers. But releasing often is pushing us to refine the processes that we have to release often to make sure we can do it as quickly as possible. Engaging our developers and designers, making sure they're really buying into the feature, making sure they're cleaning up all the little problems that would otherwise go unsolved in the product as we're going along. We don't want to have the big brother approach where someone's coming along and tapping people on the shoulder. We want our whole team to be tapping each other on the shoulder and saying, hey, you missed that there. And you go, yeah, right, thanks, mate. I'll go and fix that. We need to parallelize our feature development as much as possible. We're breaking it down into small features and working on as many things as we can at once. Not too small so that it's chaos, but small enough so that we've always got something to release. We don't have to worry about what we're going to put into the next release. And we've got our innovation week work we can throw in whenever we need to, or whenever we've got a great innovation week feature. Quality code won't slow you down, and I like this one, right? And this is coming from our development team. This is, as I said, this is one of the first values of our development team that they identified. Dev speed through quality. Your CI is super important, right? If you can trust your CI to be testing everything, then you don't need to worry. Initially, when we put out a stash release, I would download that stash release from Atlassian.com and I'd extract it and run it up and went, oh yeah, it looks like it's pretty good. I don't do that anymore because our builds do that, right? That's all automated. When whatever is up there on downloads.atlassian.com has already been extracted in one of our builds and run up and tested. Right? I don't need to do that. I don't need to worry about it. We've got a really high level of confidence in the CI that we have. And automate everything. Try and push the boundaries of getting rid of all those manual processes that you have that take lots of time. This one's really important, and it's actually really hard to do because there's a lot of stuff that's in people's heads about those processes that you don't do very frequently. And you rely on key people, and sometimes those key people like being relied on. That's sort of me. But it's really important to let go of that and actually say, well, look, I can work on bigger things actually if I'm not worrying about this, and I can delegate. I don't have to worry if I'm not here, if I'm off sick. My whole team can do this whole process. So that's about how I'd sum up a lot of the lessons we've learned. I wouldn't say that it's all the things that we could pass on to you, but that's all I've got time for. This is where we've ended up. We have our customers tweeting things like this. And this is pretty gratifying for us as a team to see people tweeting things like this. Subsequent to Scott's keynote, I've actually seen tweets like this as well, talking about Stash, and it's awesome to be here and to be getting that sort of feedback from people. Part of the reason we can get to this point is because we put a lot of effort into moving fast and moving rapidly, and we're now at a point where we believe we've got all of the key features that our competitors have, and indeed we've got a couple of key features that they don't have at all. And we're going past them. We're really focused on making sure we've got the best Git enterprise hosting solution. All right, thanks for your time.
Cool. Thank you, everyone.